everyone, welcome back to my channel, The Data Engineering Experience. So if you are new into data engineering or just curious about how to work with massive data sets in a more flexible way, you are in the right place. Today we are going to talk about an exciting update in Google Cloud BigQuery, the pipe syntax. So by the end of this video, you will understand what pipe syntax is, why it's a game changer, and how can you use it to simplify your queries and make your code easier to read and maintain. So yeah, let's dive in. So SQL has been the backbone of data handling for over 5 decades. It's loved for its declarative syntax, meaning you simply tell the system what you want instead of explaining how to get it. So this approach keeps the things very straightforward when you are dealing with data. But yeah, let's face it, SQL can get pretty messy, especially as queries get more complex. One main issue with this traditional SQL is its strict order of operations, like from, where, then group by, then order by, and select, and so on and so forth. So this order doesn't always match the way we think. So we end up with subqueries stacked within subqueries, leading to code that is tougher to read and even harder to debug. That's where the BigQuery's pipe syntax comes in. So pipe syntax is an alternate approach to address some of the frustration that you get with standard SQL. So with this pipe syntax, you are not bound by a fixed order of operations. You can sequence your actions like selecting, grouping, filtering, or joining in any order as many times as you need. The key advantage here is that the linear structure of this pipe syntax, where the code you write mirrors the steps you logically take to build the final data result. So this makes the queries easier to follow since they now exactly follow the step-by-step approach in the same order that you think about them. Another important thing about pipe syntax is that it doesn't change how Google Cloud SQL processes, prices, or optimizes your queries. It behaves exactly the same way as your traditional SQL syntax, just a more flexible layout. However, it's still a good practice to follow Google Cloud SQL guidelines for estimating your cost and optimizing your queries, even while using this new pipe syntax. Now let's get into some common example to see how the syntax works. First we have the from clause here. So if you need to select data from any table, you can just use the from clause followed by the table name. So we have the taxi trips partition data set here. So if you want to select all the columns from the table, you can just use the from clause here, and by default it will explicitly select all the columns from the table. So we can use the where clause to filter out the data. So first we need to use the from statement to select the data from the table, and then use like consecutive where clause, or we can use like and operator to have two of this filter statements together, or this two of this where statement together. So it can be done in that way. Then we can also use aggregation functions, like if we want to sum the data, so we can sum up the fares using this aggregate keyword and then the sum function of the fare, and then alias it as total fare, and then group them by the payment type. So by default it will uh, calculate the sum of the fares and then group by the payment type. So we will get a distinct sum for each payment type. We can also consolidate aggregations together. So we can find the average of the trip miles and count the total number of trips together using the same aggregate keyword followed by a group by clause. So this group by clause will group the data by each company, and we will get the average trip miles and the total trips per company. We can also add new columns, and we can add a specific calculations to it. For example, if the trip duration is in seconds, we can divide it by 60 and get the trip minutes in its equivalent form. So we just need to use the extend keyword for that, and then we can use the select statement to select various columns. you can see that this trip minutes is directly available within the select clause. So if we need to modify existing columns in a table, we can use the set operator. So here we are using set operator to convert the company names to its uppercase. So we will simply use the set operator, then pass this company name as a parameter to this upper function, and then select the distinct company type. So we will get the result. But one thing to notice, this set operator isn't in place, so it will only convert the data in the uppercase inside the select statement that you are doing. So it will not do any type of modifications in your source table. And similarly, we have this rename function here. This is an equivalent of aliases or the as operator that we earlier used in the standard SQL. So we can use this rename to rename any column to its new column name. But this operator is also in place operator, so it's only applicable in the select statement you are performing, and it will not modify your underlying tables. Next, if we want to remove any columns from your select statement or from your table, we can simply use the drop keyword. So this drop statement removes this column from your select statement, and it will work similar to like the standard SQL, which is like select star except your column names, and it will eliminate those columns while you are selecting the data. Similarly, in your standard SQL, we had a operator where you can query only a specific portion of your data randomly. So you do not need to query the entire table to just get a view of it. So you can use that table sample system type with a 10% passed as an argument. So it will randomly select the 10% of your data from this date partition table. Next, we have the pivot and unpivot operators. So if we want to convert rows into columns, basically, so you can use this pivot operator here. So the syntax is quite simple. You use this pipe symbol followed by the pivot keyword, and then the sum of the column that you want to aggregate, and then the distinct column types that you want to specify. Similarly, you have the unpivot operator where you can unpivot the trip count based on the count of trips per quarter. Finally, we have the join operator here. So we will be performing joins between two tables, and the join will be performing will be the left outer join. So we have this left hand sided table here. We will select all the rows from here, and then select only those rows from this right table where we are able to match this unique key, and the trip date is 29th, and the additional fees that is not null. Then we use this select keyword and use this aliasing that we have used here, the taxi trips aliasing and the taxi fare data aliasing, and select various columns from this two tables and then display it. So right now we are in the BigQuery UI. So let me just show you the table first, like how it looks like. So you can see it has various columns like trip date, the unique key, the taxi ID, the trip start date, end date, and various details related to this taxi trips dataset. So yeah, let's query the table. So you can see we can directly query it from the where class, and it's selecting all the columns by default. Suppose now we want to filter the data based on a trip date, and where this trip miles is greater than 5. So this trip date is my partition column here. So if I run it, we can see that it's querying only that day's data, and even in the job information we can see that the byte processed is only 7.52 MB instead of this full table. Then we can also use the aggregation function here, like if we want to sum up all the fares for the payment type on that particular date. So yeah, this is the total fare per payment type. Then let's move on to the other aggregation functions that we just saw. Let me run it. So you can see that various company names, the average trip miles, and the total trip counts. Similarly, like for this trip date, we can view the trip duration in seconds and in minutes. So this is done using this extend operator that we just saw. So here is the same duration. We just divide it by 60 and we are getting the trip minutes. Then we can see I am setting the company name to upper case and we will get the filter out data of the distinct company names. So yeah, this is the company name. All are in caps, but if you view the underlying table, the company name be in lowercase itself. Then if we want to rename a particular column, that also we saw how to do that, and let me show you how it looks like. So we will just rename the trip miles to distant miles, and you can see that it's showing up as distant miles. But if you actually check the table, if you filter distance miles, it doesn't exist because this is in place. So all the modifications happen within the select statement. So this is a similar thing that we did that we saw in the earlier statements. So if you want to drop particular columns, you can drop it or you can select it on its behalf. Then we have this table sample system where we randomly select 10% of the data. So yeah, the query is running, and if we can see that it has randomly select 10% of the data, and the bytes process is only like 247 MB. It's the exactly the 10% of the entire table. Then let's check the implementation of this pivot function. So this will take some time because it's performing on the entire data set. So we can see it has created those three new columns, and we can even see like how much is the cache. So this was the cache trip, so it is showing the cache data. Finally, we will move into the join query statement here. So I have randomly inserted two of this unique key IDs, and then we will join with the actual data and then check what will be the additional fees for them. So you can see that it has done a left outer join, and we can see this additional fees of 22.5 and 18.0 against that particular unique key from the main table. So let's check the advantages and limitations of using the pipe syntax. So as we already realized, the learning curve for this pipe syntax is very simpler if we compare it to a standard SQL. Then this pipe syntax makes your code more readable. Then the syntax is quite similar to like PySpark or the Spark data frame API. If you are already familiar with it, so you can relate that yeah, the syntax is quite similar to the data frame API from PySpark. Then this pipe syntax is interoperable with standard SQL. So you can have like 5 lines of code with standard SQL, and then you can have the pipe syntax following it. So they would work seamlessly and you won't get any compilation error. Then the limitations is like you cannot include a differential privacy clause in the select statement following a pipe operator. So if you want to know more about this differential privacy clause, you can check the official BigQuery Google's documentation regarding it. So this is a limitation of that. And then you cannot have a named window in a pipe syntax. And finally, what I feel is that the adoption to this standard from the standard SQL to this pipe syntax would be difficult, because as you already realized, the standard SQL has a very wide user base. So at the moment I can see like there would be very much little migration from your standard SQL to your pipe syntax, but I think yeah, that will change down the line. Finally, we have reached the end of this video. So if you liked my content, please like and subscribe to my channel, and please share your comments or feedbacks, anything that you have, and I would be very happy to address them. Thank you and see you in the next video. Goodbye.